Thanks, Ted. So Ted mentioned at the beginning of the three talks. My thought is it's a vector. You go from a wonderful student preparing his dissertation to one who just finished it to one who's published it. So it's a nice sense of what happens to the GTU and beyond. And this is the publication. Kirk's book, The Entangled God, Divine Relationality in Quantum Physics, 2011. So it's an excellent book, very complex book. I'm going to give you a brief look at the book and then open up for questions. Okay? So a first look at Kirk Wegter-McNelly's book, The Entangled God, and we'll try to untangle some of the tangles. So he starts off with a wonderful discussion of relationality in theology and just cites texts from some of the key folk. There are probably 20, 25 people listed here, but some of the main ones are on the screen. And his basic question is, can quantum mechanics provide a new rich source of metaphors for such theological relationality? So he's going to accept relationality in theology, but try to understand it better with metaphors from quantum physics. So to set the stage for quantum physics, he goes back to classical physics and talks about three themes that define classical physics. So property definiteness. If some physical object has a property, it will necessarily have that property in a determinate or definite way. Together, the values of all of its properties comprise the object state. I'm going to give you the example in a second. Braden, is there any water?
Take that.
Oh, thanks.
I don't have jars.
Thanks, Dad. Appreciate that. Second is state separability. One can fully describe the state of a system as something that belongs to the object alone, separately from the states of other objects. And causality. The causal interaction of distinct objects is always mediated by a series of local events. The essence of mechanics is contact force. So here's an example. So two of us are walking into the room. Kirk comes in first, I come in second. The state of being in the room is unambiguous for Kirk, and being out of the room is unambiguous for me. The fact that he can hear me talking obeys the causal principle because, of course, it's conveyed by air between us. And Kirk being in the room isn't dependent upon my not being in the room. So the states are separate. Yeah, okay. And those three definiteness ways of being in the world are presupposed by classical physics. And they really are rooted in common sense. So, quantum mechanics. The famous two-slit experiment with photons. In that experiment, property definiteness is challenged when an individual photon apparently travels through both slits at the same time. It'd be like saying I'm in the room and not in the room. Okay. So that is challenged. And causal locality seems to break down when a measurement causes an indefinite property to become definite. This is referred to as a collapsed wave function. So if you don't measure me, I'm in the room and not in the room. But if you measure where I am, I'm either in the room or not in the room. So and that can be interpreted as a kind of violation of causality, because one state ceases to be and the other one becomes normative. Now, the more sophisticated way of talking about this is quantum entanglement. So Schrödinger, back in the late 30s, commented on the famous Einstein-Podolsky-Rosen paper. The fact that two systems which have interacted can never be thought of as fully separate until a measurement is made, he saw this as the characteristic trait of quantum mechanics, and it enforces its entire departure from classical lines of thought. Now let's look at an example. So entanglement as a superposition of two states, two particles A and B. The initial state, particle A, can be up or down, so think of spin up or down. So A up or A down, same for particle B, up or down. And the combined state is a superposition of A up, B down, plus A down, B up. Now, why you have both those is, in fact, again, superposition. If either one can happen, both can happen. If this representation weren't true, you wouldn't have chemistry. The color of Braden's shirt depends upon that fact. So the combination of up and down for both is essential to quantum mechanics, essential to explain the world. Now, entanglement is a non-local correlation of two particles. The initial state we just had. Let this state of two particles cease and the particles go off to a large distance. Measure one or the other, and they're always correlated. So if you measure A up, B will be down. If you measure an A is down, B will be up. But the combination or superposition is broken. So again, you've got this problem of causality. How could the measurement that Braden makes there affect my results here instantaneously? Now, there are two schools of thought as to how you explain that. One that's quite frequent is, in fact, what I just said, that there's a breakdown in causality, breakdown in special relativity, that there's an instantaneous cause, right, a superluminal cause that goes from A to B. Most scientists don't want to go that way because abandoning special relativity is just too painful. Quantum mechanics and relativity are the foundations of modern science, and to have one be at the cost of the one is not the way you want to go. The other one that really Kirk is using, and is much more complex, is to say, in some ways, once they are in this state, A up, B down, plus A down, B up, they're always in that state because they're actually ontologically in that state. No matter how far apart they are, until you measure them, they were in that state. So their ontological character is not local, or it's entangled. Entanglement has become a kind of more useful term for that, but they're getting the same thing. Superposition, right? Non-locality, entanglement, they're getting at the same sort of problem. And that is that there is a relation between the particles that can't be broken by separation. It can only be broken by observation. If you measure it, you lose it. But until you measure it, it's actually there, even though they're light years apart. Now that's the more philosophical solution. And scientists vary. I mean, some will just take a more pragmatic solution, say these are statistics, they predict the results of the experiment, but they don't have ontological significance. If they do, we don't care about it. That's for philosophers. More philosophically minded scientists and philosophers of science typically take the ontological approach and say, yeah, science has finally revealed that, in fact, there is this subtle problematic of the world that John alluded to. That is, there is a one in many problem. And it's not just epistemological. Our knowledge points to what's real. It's ontological. So Kirk will follow the second route. He doesn't go the superluminal route. I think that's been pretty discredited. People like Michael Redhead have argued strongly against that. You can't signal. If Austin makes a measurement, he can't make a measurement such that it affects me that I know he made a measurement. I only know he made a measurement when I compare his results with my results afterwards, and I find a correlation. But the fact of measurement doesn't, it's really hard to say. It actualizes without carrying information. So it's, in a subtle way, it doesn't violate special relativity. Anyway, that's aside, I'm sorry. And just to finish up, entanglement violates property definiteness. The first state, remember the one you have to have in, say, an atom to have chemistry, to have the periodic table of elements. The first state is A up, B down, plus B down, A up, or minus. This is very subtle, because this is Kirk's whole argument. There is a state property that is, both of those states have zero spin. A up, B down has zero total spin. A down, B up has zero total spin. And zero total spin is state definiteness, state property definiteness. But neither particle has spin definiteness. A is both up and down. It's up when B is down, and it's down when B is up. So the combined state, the entangled state, has state property definiteness, but its substates don't have property definiteness. Now that's what Kirk says is the most important way to interpret this problem. So this is Kirk's chapter 5, when he's giving a variety of interpretations of quantum mechanics and saying his interpretation, which is pretty unique. Not many people follow it. He's very gutsy in doing this. His interpretation really points to the break with the classical worldview, with those three themes I began with. So here's his way of speaking about it. He goes back to an example which we used to kick around when we were teaching it together. I would typically say water has the property of wetness and weight. So the water that Ted gave me, not the container, but the water Ted gave me, has both weight and wetness, or it's got a surface, it's superficial. A mosquito can walk across it. Now, the wetness of water is a property not dependent on H2O molecules having wetness. The wetness of the water is a holistic or emergent property of the ensemble of molecules. It's not a property which results from having the same property on the subparts. An H2O molecule doesn't have wetness. Okay. Whereas the weight of the water, right, the weight I feel when I lift it, is a property that depends upon H2O molecules being or having weight. So to put it in the technical language, the wetness is an example of emergence. A property arises at the level of the state, which is not reducible without remainder to the properties of the subparticles, substates. Whereas the water is not an emergent property. So in almost the same language, you can say emergence and non-supervenance agree, and non-emergence and supervenance agree. To say it a little more carefully, supervenance means that a property at one level reflects the properties at a lower level. That's why an emergent property is non-supervenient. Okay. So the state of the entangled system is A up, B down, plus A down, B up. The property state has zero spin, but the particle state has indefinite spin, up or down. Violates classical property definiteness. The state property spin is a property that the particles have as well. Having the property of spin is a property the particles have as well as the system. But having a definite spin is a property only of the system and not of the particles. So it's a complex way of saying it, but here's the kind of diagram I try to make of it. I wasn't very good with my coloring, so you have to forgive me. But if you compare classical physics to quantum mechanics, you can see how they lay in different realms. If you compare supervenient and non-supervenient properties to emergent and non-emergent properties, classical physics assumes these two. Sorry, this is light blue. Classical physics is here, wetness and weight. Quantum physics is here. So it's neither here nor here, and nothing's here. So it's a complicated technical way of getting at how quantum physics, which we usually think of as being a theory of holism of some kind, that would be Guido Capro's motion, for example, isn't really quite that simple. It's really actually very subtle, because it's not as holistic as a fully emergent system would be, which occurs in classical physics. But it's not as non-emergent as other phenomena in the classical world. It's a third kind of phenomenon. Okay. So, just to summarize, the wetness of water is emergent because it doesn't supervene on any property like wetness of molecules. It's a truly new property. The weight of water fully supervenes on the weight of molecules and doesn't emerge. The spin definiteness is a tertium quid. It is fully true for the system, but not for the particles. But it's the same property that's fully true for the system as for the particles. Same properties like wetness. doesn't, fully definite for the whole is like, same property is like weight, fully emergent is like witness, and it's a third tertial quid. Okay, now, that means that for the rest of his book, the task Kirk has set for himself is to try to use that notion of relationality to talk about Trinity. Now, I'm just going to go through this quickly. And I think it's a very complicated argument. I'm not sure if he's right. And it's not simple. So I'm in relation to it. It's always wonderful when your own folk that you taught have gone beyond you and have challenged your own thinking. So I'm challenged by Kirk's book. It's a wonderful read. So let me just say, I'm going to name for you some of the applications. He does in great detail, and then open up for a couple questions. So he started with a first chapter talking about how important Trinity and relationality in Trinity is for contemporary Trinitarian theologians. Then he went to quantum mechanics and said, on the surface, this must be a really good place to find some metaphors for relationality, for emergence, for the ontology of being in relation. And then he looks at it carefully and says, well, it is, but it's also in your face, because the metaphors that it gives you are not classical metaphors. How can something be like witness and like weight, but not like witness and not like weight? What else is there? So he starts off with this fundamental assumption: the Trinity is fundamentally entangled within God's self and freely entangled with creation. Now, it's not pantheism. He's certainly not that. It's not even panentheism, but it's not classical theism, because he uses the same model of entanglement to talk both about the immanent Trinity, right, where the persons are the relations, and the economic Trinity, where the revelation of the immanent in nature is in a nature which is created by that same entanglement. So he goes into a long and interesting discussion of creation ex nihilo. He doesn't side with the process of people by rejecting it. He doesn't flat out take it on board. He's got an interesting sort of dialectical hermeneutic as to what it means and what it gives you and what it doesn't give you. If you use this notion of the ontology of relations from quantum entanglement instead of from ordinary life, like spousal relations or family relations or whatever. The world is to be regarded as the product of a Trinitarian relational act. So in his view, creation is a relational act, because the concept of creation is itself a relation between the within of God, God's self, and God's ad extra argument, ad extra act, that is creation. Two, three more, we'll finish. Wonderful vestigium argument. Barth was famous for rejecting vestigium as an argument from nature to God. But he allowed it. I think his footnote was 20 pages on why you can't do it that way. But at the end of it, he says, but it's fine to say, well, if we're the creation of a God, Trinitarian God, there will be vestigia of that in nature. It's just you don't look for the vestigia to find out about God's nature, but you can see it as a reflection of it. So Kirk makes the same move. Quantum entanglement can be viewed as a theological vestigium within creation. So in a certain sense, you wouldn't be surprised to find out that there's a quantum mechanical form of relationality called entanglement, which is just more subtle and different from the classical world of relationality, right? I am who I am, Charlotte is who she is. We entered a relation of marriage, and the relation helps define who we are. That's wonderful. But quantum mechanics gives you a metaphor of relation which is different. And so he's exploring that differently. God becomes freely and lovingly entangled with the world through the act of creation and in the world in response to acts of violence on the cross. So he explores the distinction between God's relation to the world as creator and God's soteriological relation to the world as savior, the cross. using this hermeneutics of entanglement as relationality instead of the ordinary garden variety notion of relationality. Quantum entanglement is not rightly understood as a physical form of modalism or as a weakly differentiated form of monism. I mean, he goes after theologians who would argue that the best way of talking about Trinity is through, the three masks God puts on. There's one person, there's three persons, which are kind of representations of the one being. He rejects that again with entanglement. That would be a kind of emergence argument, that the persons emerge from the underlying reality. And he's saying you don't have full emergence in quantum mechanics, but you don't have full non-emergence. You have this third thing called entanglement. Right? So entanglement doesn't drive you to Sabellian modalism, because there's no such category of a unified thing with its three representations. Right? That breaks down. We can do it. We can act in a play. I can be me, and I can act, and I can act again. But that isn't what God's doing. Or a weakly differentiated form of monism. That is that the entangled properties are different enough that they aren't just the properties of the objects being entangled, right? The wetness of water, the state definiteness of spin depends upon the states of spin of the particles, even though the state can be definite in the whole and not definite in the parts. So it's not as weak as just saying, well, the weight of the water is the weight of the molecules summed up. No, there's a kind of emergence there, but it's not that huge. So quantum entanglement is not understood as a form of weakly differentiated monism. It points instead to a relational holism that intertwines the existence of part and whole, such that relations among parts bear the state or the identity for God of the system as a whole, as relations. And then finally, if the behavior of an entangled whole is only unambiguously affected as a whole by the entangled relationships that exist among its parts, then the entanglement of God with and in the world, Creator and Redeemer, implies a transforming relationship between God and the world that nevertheless leaves room for the world to continue to be itself, suffering and evil included. His theodicy, a little like John Polkinghorne's, is that God leaves the world free to create itself. But unlike John's, John talks about immanence, which is good. It's not a spatial separation. God isn't out there. None of us have. But Kirk has a much more fully immanent view of God. It's precisely because of this entanglement of properties between the whole and the parts that it's precisely God's entanglement with the world which leaves the world free. That is, it's the presence and activity of God which leaves the world to be free to be itself, not the transcendence of God, or worse, with Moltmann, God withdrawing from the world, right, to give the world space to be. Instead, God is, as Ted was saying, fully present, fully real in the world. God is the wind beneath wind beneath your wings. Our freedom is because God acts in us. And what Kirk is doing is taking that, but giving a quantum mechanical metaphor for it, which both amplifies the meaning and challenges the sort of ordinary connotation of it. Okay. So that's his response to theodicy. That is, God is acting, and that action is the effect of that action is, in fact, our freedom, which includes our freedom to sin and the brokenness of the world. Okay. So there's more. I invite you to read on. Cheers for Kirk. Good job, Kirk.